So we are starting with sets. As always, because we know that topic 1 is quiz 1. So learning has been on for some time now. And tutorials are starting this week. That means that within this week, we should be told of when the quiz is likely to be. So not next week, but then the week after next week should have a quiz. Either announced or just a surprise in our tutorials. So we should at least know when you have a tutorial, especially you guys at Ridgewell. You must know when you have a tutorial. At least if you're unable to attend a tutorial, to attend lectures, but pick an hour when you're able to attend the tutorial so that if there's anything in that tutorial, you are aware. Okay. So we'll go straight into examples. One, find A intersection B, A complement union B, B complement, and B complement intersection A. A given A is equal to negative infinite, comma 4, and B is equal to negative 10, comma positive infinite. The universal set is R, the set of real numbers. Okay. Solution. So I've put 5 questions just to emphasize on some important and key things that one need to know when it comes to sets, and especially to deal with intervals. So we've taken the universal set to be the set of real numbers, and then we'll stream, maybe in some other examples, we'll pick small size sets. So now we go to 1. We want to get A intersection B. So A intersection B. Here, there are 2 things. You may opt to go for a number line or just use the observation technique, where you say, okay, on my left, for the 2 sets to intersect, and for me to get the intersection, there are 2 things to observe. The first thing is that for the left ends, negative infinite or negative 10, we need to pick the number that is bigger than the other. So negative infinite is way below negative 10. So we'll pick negative 10 as our left boundary for the intersection. And on the right, you pick the number that is smaller than the other. So 4 is way smaller than infinite. So we pick 4. When you pick a number, you pick with its closing bracket. So you check whether the bracket is open or closed and take it as it is. So we've picked negative 10, which has a closed bracket. We have also picked 4, which has a closed, which is an inclusive closing. So we're saying this is our intersection. Now, suppose you can't see it from this end, you may as well opt to go on a number line so you can visualize. On a number line, the universal is R, and then we have 4 closed going to the left. We also have negative 10 closed going to the right. Okay? So if you want to talk about the intersection, you want the interval that is being shared by the two intervals. So here, we have from negative 10 all the way up to 4. Hello, is there a concern? Hello? So you see that the intersection includes negative 10 and positive 4. We got part 2. Part 2 talks about A complement. So the complement of A is a set that is within the universal set, but not part of A. So it's not in A, it's that part which A leaves out. Okay, so since A takes from negative infinite up to 4, including 4, it means that the complement, A complement, is going to take 4 as a boundary, but won't include 4, and go all the way up to infinite. On the number line, you have R there, and then you have 4. Closed, going to the left, is A. So this part is A. So the complement, you need a boundary. So the same 4 will be a boundary, but then you won't include it. Go all the way up to the end. So this will be A complement. The piece that is not in A, so the piece that has been left out by A in the whole universal set is what we call A complement. Now, funny enough, is when you go to part 3, where you want to look at what is not in A plus what is in B. Now here, some things that you think are obvious, that you think are obviously true, may be violated. Okay, so A complement has come out to be, so A complement has come out to be 4 positive infinite union B. B is from negative infinite, from negative 10 to positive infinite. So now see, the union is going to be Between 4 and negative infinity, now you get the lower number, the smaller one, negative 10. And between the two infinities on the right, you pick n of them. But you're supposed to pick the bigger number again. So we pick that one. On the number line, we will have, so remember, we had area negative 10 to infinity, and then 4 to infinity. Now the union will be everything. So it'll just be negative 10 to positive infinity. Okay, we go to part 4, B complement. So B complement is just the opposite of B. So it will be from negative infinity up to negative 10, again, not including negative 10. The infinities we never include because it's just a symbol representing, just communicating to us that, well, we keep going on the left, we keep going to the right. And then part 5, B complement intersection A. Let's see, B complement is negative infinity to negative 10, intersection A, which is from negative infinity to positive 4. So here we have negative infinity all the way up to negative 10. Because if we go beyond negative 10, trying to cover the space up to 4, we will remain with only one set. The other set would have ended at negative 10. The idea is we are picking the intervals that are covered by 2 intervals. So there's an interval, another interval. So now I want to pick where they are sharing a space. Okay, so which space is common? That's the one that you're picking here. Okay, so on the number line, we are going to have negative 10 to minus infinity and 4 to minus infinity. So you're picking the common one, like that. So that's the common piece. Any issues arising?
So can you kindly repeat on B complement number 5?
B complement intersection A.
Yes, please.
So there we have a B complement first. We have B complement first, which is from negative infinity up to negative 10, and it does not include negative 10. We are intersecting it with A, which runs from negative infinity up to 4. So negative infinity up to negative 10, and then negative infinity up to positive 4. So we want the common interval. Which interval is shared by the two? So we are seeing that this is the interval that is shared by the two. Up to there. So that space from negative 10 to 4, we leave it out because it only has one interval. Intersection demands that we should have all the intervals B complement and A meeting. So that's why we get only that space.
All right, so thank you.
Okay, we go to example 2. So example 2, given A is equal to -1, 0, 1, 2, B equal to B equal to 0, 7, 8, 9. And the universal equal to -1, 0, 1, 2, 3, 7, 8, 9. Find 1 A complement, 2 A complement union B, 3 A intersection B complement. So let's see A complement. So this is now the definition of a complement. It's well understood when we come to this part. A complement, we are going to the universal set and write all the numbers that are not in A, all the elements of U that are not in A. So we have 3, we have 3, 7, 8, 9. So we leave out -1, 0, 1, 2, because those are in A. In A complement does not take any element that belongs to A. That's why when it came to intervals, we were skipping. We were just, if it was closed, we were opening because it cannot be in both sets. Part 2, A complement union B. Okay, that is the complement that we have union B. Okay, this is now the one that will help us understand why what could be in A finds itself in A complement union B. Okay, so now A complement union B means get whatever is in A complement plus what is in B, put them together. to form a new set. So the new set will have 0, 3, 7, 8, 9. Even if 0 is in A, it has appeared in A complement union B because 0 is found in B. So we are combining what is not in A plus what is in B. Part 3, A intersection B complement. A intersection B complement. So here now we have what is in A intersection what is not in B. So let's get B complement. So B complement will have -1, 1, 2. So we'll leave out 0. Okay. So 0, 7, 8, 9. Those are in B. Okay, so we go to, so the intersection is -1, 1, 2. So these are the common ones. These are the common ones. So those are the common ones. That's what we put in the intersection. So let's also try to understand these two laws. So A intersection B complement is equal to A complement union B complement. So that's the De Morgan's law. Okay, the De Morgan's law. So let's see if it's true. So let's get A intersection B complement. So we need to get A intersection B. A intersection B, and there's only 0 common. So now we get its complement. So that will be a -1, 1, 2, 7, 8, 9. That is A intersection B complement. Now let's go and get A complement union B complement. So A complement. We said it's 7. Well, there's a 3 also. There's a 3. So in B complement, we also need to put a 3 here. Okay, yeah. So we need the 3 here. 3, 7, 8, 9. That's A complement. Union B complement, -1, 1, 2, 3. And then get the union of that. So the union is -1, 1, 2, 3, 7, 8, 9. The question is, are these two equal? Are these two equal? So yes, they are equal. There's -1, there's 1, there's 2, there's 3, there's 7, there's 8, there's 9. So it means that Morgan's law is actually true. This just helps us to appreciate it. So you can also check if A union B complement is equal to A complement intersection B complement. So just check the properties. I've given you very easy sets that will help you check a lot of properties that you may want to try. We want to say, okay, A intersection B union C. Is it the same thing as A intersection B union A intersection C? Are they the same? Are they the same? Okay, is it true that A union B is equal to B union C? I mean B union A. So here, so for this one, I'll need to add for you C. Let me add for you set C so that you can try. So set C, -1, 2, 2, 3, 7. -1, 2, 3, 7. So I just want you to use them to try and see if these are equal. A intersection B, is it equal to B intersection A? Okay. A intersection empty, is it equal to A? Just try and see if they are true. A union empty, is it equal to A? So A intersection empty must be equal to empty and not A. Is it equal to empty? So just try and use them with those sets to see these properties are satisfied. So began our process. This week we'll see how far we go. Tomorrow we'll also have another class. Maybe the tomorrow one will be a bit longer than today because I've just seen that some people are able to join and then they were locked out, maybe network and the like. So we'll see what happens. We need to recover a bit of some time that we lost last week. Since now the invest is fully running, so we need to move a bit fast, slow, but fast. Okay, have a good night.
All right, sir. Thank you.
Thank you, sir.